This is my pre-algebra course. In the last class, we learned how to evaluate algebraic expressions. In this class, we're going to continue to evaluate algebraic expressions, but the expressions in this class are going to be a little bit more difficult. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. So, we learned in the last class that to evaluate an algebraic expression, we have to see what this expression equals when we plug in 3 for x. So we're going to go ahead and do that. Rewrite the expression, but every time you see an x, you replace it with negative 3. So again, we have x, we placed with negative 3 here. We have an x here. We replaced it with negative 3 here. We also learned a lot of different operations in the last class. We learned how to square a negative, and we learned what to do when you have a negative in front of the x squared and all types of things. So this is something that you should know if you did the homework. Negative 3 to the second power. And by the way, when you plug in this negative 3, you've got to put these parentheses here. Remember, most students will tend to write negative 3 squared without parentheses, and that will be wrong because you'll get a negative 9, and this expression is not negative 9. It's positive 9. Because the x is negative 3, and if you square x, you have to square both the 3 and the negative. So negative 3 times negative 3 is positive 9. Do not write negative 3 squared without parentheses. That is incorrect. And we have negative 2 times negative 3, which is positive 6. And you can write this with a double negative, but it's just going to take more time. Add those up and you get 16. So that's our first answer, is 16. Let me just double check that. 9 plus 6 is 15, plus 1 is 16. That looks correct. So let's try number 2. But now we have a negative in front of the squared term. So when we plug in the negative 1, we still have to use parentheses. But because we have a negative here, it's going to change the sign slightly. And so now we've plugged in the value for y. So we plugged in negative 1 every time we see a y. And then we're just going to follow order of operations. So we do exponents, so negative 1 to the second power is positive 1. So that ends up being a negative 1. And then remember, when we have operations in the numerator of a fraction, you have to perform those operations first, even though it seems to violate the order of operations agreement. So negative 1 plus 2 is 1. And so now we just have to combine these numbers. To do that, you can change these ones to fractions, multiply both sides of this fraction by 3 and both sides of this fraction by 3, and you get negative 3/3 plus 1/3 minus 3/3, and you don't really have to show all that. If you can do this in your head, that's fine. Negative 3/3 plus 1/3 is negative 2/3. Negative 2/3 minus 3/3 is negative 5/3. But again, you can do that. You can do that in your head if you feel comfortable. Let me just double check that. That looks correct. All right, number 3. So now we have a negative in front of the power term, but we're plugging in a positive this time, so this is going to be slightly different. In this problem, we don't have to put parentheses here because we're plugging in a positive. So we learned that in the last class. There's nuances for this language that you must know with experience. So again, we're plugging in that 2 for z. So we do the PEMDAS tells us to do parentheses first. So we're going to, I'm just going to rewrite the, actually I don't need to rewrite that. We can just do that at the same time. So 2 to the 4th power is 16. And then we'll do the parentheses. 2 plus 1 is 3. And we need to keep these parentheses here because the parentheses tell us that we're going to multiply this square by 7. So you need to keep those parentheses. So negative 16, and we're going to do the power next because PEMDAS tells us to do exponents. 3 to the 2nd power is 9, and we need to keep the parentheses. Then PEMDAS tells us to do multiplication, and the multiplication is shown by these parentheses. Remember, in algebra, we use parentheses for multiplication. So then we get negative 16, and 7 times 9 is 63. And now we have addition and subtraction, and PEMDAS tells us to move left to right. So negative 16 plus 63 is 47, I believe, and 47 minus 5 is 42. So we got 42 on that one. All right, on to number 4. So again, we're going to evaluate this expression when x equals 2. So we're going to figure out what that expression equals when x equals 2. And I should probably move this down a little bit. So I plugged in 2 for all the x's, and we have to simplify the numerator first before we divide by 7. So in the numerator, we have to do exponents first, PEMDAS tells us. And then we can add. So we get 4 plus 3 is 7. And that becomes 1. 7 divided by 7 is 1. And then 1/2 plus 1 is 3/2. So hopefully by now you understand how to add these. I don't want to keep doing that over and over again because you already learned how to do that in my arithmetic course. And I've already showed you how to do it in the last class and this class. All right, so now it's your turn to try. Go ahead and attempt number 5, and when you come back, we'll do it together. All right, we're back. So we're going to plug in negative 1 every time we see an x. And by the way, I just want to remind you, you see how on this problem, when I plugged in the number, I didn't write parentheses here. That's a special case where I didn't have to write parentheses when you have the coefficient of 1. And I didn't have to write parentheses over here. So they're on this power expression. So there are certain situations when you don't have to write parentheses, but in most cases you do have to write parentheses. We didn't have to write parentheses on these because the coefficient of the power term was a negative 1, and you don't have to write 1 on this one. But on this one, the coefficient was a positive 1. Whenever you have negative 1 or positive 1, and you plug in a positive number, we plugged in positive 2, then you don't have to use parentheses. But if you plug in a negative number, you always have to use parentheses. And of course, if you have any kind of positive or negative coefficient, you have to use parentheses. So I know that's a lot to think about, but again, you're just going to have to learn fluency. If you had to explain your language, the language of your native tongue to somebody else, you would find that it would be pretty difficult. It would be hard to explain. But somehow you have it figured out. Why? Because you've practiced. So that's how you learn fluency in mathematics, is by practicing. If you don't practice, you've got zero chance to gain fluency. So in this case, we're plugging in a negative, so we have to put parentheses when we plug it into that power notation. So we've got -1 plugged in there. Let me just double check that. It looks correct. So -1 squared is +1. And -1 to the third power, that's -1 times -1 times -1. So that would be -1. And 6 times -1 is -6. Now I can write that like so, but most mathematicians are going to write the condensed form, and you need to start to learn the condensed form. So I'm going to write it with condensed form. All right, so now we have a double negative. That becomes positive. And now PEMDAS tells us whenever you have addition and subtraction, you move left to right. So 1 plus 8 is 9, and 9 plus 1 is 10, and 10 minus 6 is 4. So if you got 4, good job. Try number 6, and when you come back, we'll do it together. All right, we're back. So we are going to use parentheses when we plug it into the power function, or the power operation, because we have a negative number. All right, so we plugged in the -2 to all the y's, and now we just have to simplify. So PEMDAS tells us powers, so a -2 to the 4th power. So that's -2 times -2 times -2, and by the way, we're only raising this -2. This negative is not raised to the 4th power, just ignore it for now. So -2 times -2 times -2 times -2. That would be, if you said +16, you were correct. Remember, whenever you raise a negative to an even power, your result is always going to be positive. At least this part is going to be positive. Then we have to add this negative afterwards. That's where that came from. All right, so 3 and then -2 plus 1, we can do that. So notice that we did 2 things at once. Sometimes you're allowed to do that. All right, so now we have 3 over -1. 3 divided by -1 would just be -3, and we can write it in condensed notation, and we get -19. So if you got -19, good job. Let me just double check that. -16 plus -3 is -19. That looks correct. All right, now you try number 7, and when you come back, we'll do it together. All right, we're back. So we're plugging in a positive number to a power operation with no coefficient here. So that means we don't have to use parentheses. That's one of the rare cases where we don't have to use parentheses. But we do have to use parentheses here in this power notation because we've got a coefficient. You see, if I take these parentheses away, these parentheses here, and just write 3, then look, it looks like we're raising 23 to the 3rd power. We don't want that. So you have to write parentheses. All right, so we plugged in 3 for everything. And of course, you need parentheses here because we have to show the multiplication. 3 to the 2nd power is 9. And like I said, sometimes you can do multiple operations at once. So -7 times 3 is -21 using the condensed notation. 3 to the 3rd power is 27. So 9 minus 21, and again, PEMDAS tells us to move left to right. 9 minus 21 is -12. And actually, you know what? I should probably, that's okay to do it, but just to keep with the system, I should multiply these first. So that would be 54. 2 times 27 is 54. And now we'll go ahead and subtract. So 9 minus 21 is -12. -12 plus 54 is 42, and 42 plus 4 is 46. So if you got 46, good job. All right, try number 8, and when you come back, we'll do it together. All right, we're back. So again, we don't need parentheses here because this is not a negative number, and the coefficient is -1. Whenever you have +1 or -1 as the coefficient, you don't have to write parentheses. That's just a rare case when you don't have to do that. But when the coefficient is not -1, for example, here it's 3, you have to show parentheses. All right, so again, this is not raising the negative to the 4th power. It's just raising the 2 to the 4th power. So 2 to the 4th power is 16, and we just tack that -1 on there. If you were raising, if you had parentheses around that, then it would be positive 16, not -16. Because the negative would not just hang out, it would be raised to the 4th power, and because it's an even power, you get a positive. I don't mean to I don't mean to talk too much here, but these are all things that are extremely important. All right, so then we raise to the 2nd power. 2 to the 2nd power is 4, and 3 times 4 is 12. -16 plus 12 is -4. -4 minus 1 is -5. So if you got -5, good job. All right, try number 9, and when you come back, we'll do it together. All right, we're back. So now we definitely need parentheses for multiple reasons. All right, so we need parentheses because we have a coefficient and we're plugging in a negative number. So -1 to the 2nd power is +1. And here we have a double negative, so that becomes +1. And over here, we can actually, well, first we'll just do the operation. So 2 times -1 is -2. And we can bring this negative up. We can put it anywhere we want. So remember, it's not legal to put a positive next to a negative. That's not standard notation. So you want to put parentheses around this. But eventually, we want to consider that negative to be up here. That's the typical type of notation. But 3 times 1 is 3. So we'll just go ahead and get rid of those parentheses and the positive sign, and we'll just put the negative there. So we got rid of the positive sign here and the negative sign here. Or we didn't get rid of the negative, but we put it up. All right, so 3 plus 1 is 4. And 4 minus 5/2, that would be, if you get a common denominator, that would be 8/2 minus 5/2 is 3/2. So if you got 3/2, good job. All right, number 10. Go ahead and try number 10, and when you come back, we'll do it together. All right, we're back. Double check everything, make sure it's correct. So -2, this negative is just going to hang out there. -2 to the 3rd power is -8. And again, this negative is going to hang out too. -2 to the 2nd power is +4. And so a double negative becomes a positive. 8 minus 4 is 4. 4 plus 10 is 14. So if you got 14, good job. All right, try number 11. When you come back, we'll do it together. All right, we're back. So as you can see, we have a double negative inside the parentheses. So PEMDAS tells us to do parentheses first. So that double negative becomes a positive. And then we can do the exponents. Like I said, you can do multiple operations at once, so I could have done this part also. But I want to show as many steps as I can. So 1 plus 3 is 4, and we keep the parentheses because we're told these parentheses tell us that we're multiplying all of the stuff in the parentheses by -5. So you've got to keep those parentheses. Now we know what the parentheses equal is 4, so now we're going to multiply that by -5. All right, so then -3 to the third power is -27. And -27 times 2 is +54. And -5 times 4 is -20. So you got to have a plus sign there because that's +54. And -20 plus 54 is 34. So if you got 34, good job. All right, try number 12, and when you come back, we'll do it together. All right, we're back. Be sure to write your parentheses around the -2. And we have a double negative here, so you would need parentheses also. And of course, you need parentheses there. So let's double check to make sure we plugged in everything correctly. Looks like we did. And we're going to do the exponents first. So -2 to the second power is +4. And this is a double negative, so we can go ahead and make that a positive. Now, I just want you to be aware, if there were a power up here, then you could not multiply these first. Be aware of that. Be very careful. If there were a power here, then you would not be able to just change that to a positive. So because there's no power here, you can go ahead and change that to a positive. Otherwise, don't do that. So these are the little nuances that you need to learn with experience, with practice. All right, so -2 to the third power is, I don't know why my computer keeps bouncing around like that. -2 to the third power is -8. And so -10 times 4 is -40. And -3 times -8 is +24. -5 minus 40 is -45. -45 plus 2 is -43. -43 plus 24 is -19. So if you got -19, good job. All right, let's go to the next problem. Go ahead and try number 13, and when you come back, we'll do it together. All right, we're back. Double check that, make sure everything's plugged in correctly. And so the power first, -3 to the second power is +9. And we can go ahead and begin to simplify the denominator. 3 times -3 is -9. And we have a double negative here and no power here, so we can go ahead and change that to a +3. Okay, so -3 times 9 is -27. And -9 minus 1 is -10. So a negative divided by a negative is a positive, and this also reduces to 2/5 if you use the fundamental principle of fractions. So this is going to be somewhat difficult to write as an improper fraction, but we'll go ahead and do it because that's what we've been doing in this course and most algebra courses. So we're going to write this over 1, and if we multiply both sides of this fraction by 5, then we get negative 135 over 5. I know that's kind of a big calculation there. Multiply both sides of this fraction, if we write it over 1, by 5, and we get 15 over 5. So add those up, and we get negative 135 plus 2 is negative 133. Negative 133 plus 15 is negative 118, I believe. So if you got negative 118 over 5, good job. Now in that case, it's probably best to write it as a mixed number, but we don't have to worry about doing that now. Whoops, sorry about that. This program likes to do random stuff like that. All right, so try 14, and when you come back, we'll do it together. All right, we're back. All right, double check, make sure we did that correctly. Everything looks like it's plugged in right. So we'll do parentheses first. Now this is exactly what I was talking about. You see this? Right here. That looks like a double negative, but it's not because we have a power here. So we have to, a PEMDAS tells us to raise the negative 1 to the power 2 first. Then we can combine it with the negative if we still have a negative. So negative 1 to the second power is positive 1. And then this is definitely a double negative, so that becomes positive 1. And negative 1 to the fourth power, that's positive 1. And so we're done with the powers. So now we're going to still, and again, notice I've been doing multiple steps. PEMDAS tells us to do parentheses first, and exponents and multiplication, and so on and so forth. But in previous problems, I've always been doing it step by step by step by step. But now you should be getting to the point where you don't need me to do it step by step by step by step, because you should be more and more familiar with the language, so that I don't have to show every step, because as you can see, I don't even have enough room to show every single step. So negative 1 minus 1 is negative 2. And negative 2 times 1 is negative 2. And 7 times negative 2 is negative 14. And now we just move left to right. Let's put a divider here. Negative 14 plus 1 is negative 13. Negative 13 minus 2 is negative 15. So if you got negative 15, good job. All right, try number 15, and when you come back, we'll do it together. All right, we're back. Be sure you write parentheses there when you plug it into that x. So now this is a double negative. That just becomes a positive. And again, I know I violated order of operations there, but again, you can do multiple steps at once as long as you keep track and understand that you're going to get the same answer no matter what you do. In some cases you will, in some cases you won't, but you'll get used to it over time. So now 5 times -1 is -5, and again, I violated order of operations because order of operations tells us to do the exponents first, but it doesn't matter which one you do first. In this particular example, you're going to get the same answer. -1 to the 4th power is 1, and -3 times -1 is +3. And again, I'm doing multiple steps just because it'll take forever if I do it step by step by step. Let's see, what can we do now? Let's do the parentheses. So -5 plus 1 is -4. And -1 times -4 is +4. So again, we did this part here to get +4. And our final answer is 8. So if you got 8, good job. All right, number 16. Attempt that problem, and when you come back, we'll do it together. All right, we're back. So we plugged everything in there. And double check to make sure we did that correctly. So now we'll do the power. -4 to the 2nd power is +16, but this negative still remains because it's outside the parentheses. And -3 times -4 is +12. And we have a double negative here, so that becomes +4. And remember, we have to simplify the numerator of the fraction before we can consider the dividing by 7. -16 plus 12 is -4. So we're going to get a proper fraction, which means we can. We're not really going to divide 4 by 7 unless you want to get a repeating decimal. So now we can write 4 is over 1 and get a common denominator. And that would be -24 over 7, I believe. Actually, no, positive 24 over 7. So if you got positive 24 over 7, good job. All right, so 17 is going to be a little bit different because we have 2 variables. We have x and we have y. When 2 letters are next to each other, that's multiplication. You're going to find that out as we go along here. We're going to do application problems, and you're going to see that when 2 letters are next to each other, that's multiplication. So we have x is -5 and y is -3. So we plug those in there, and order of operations tells us to multiply first. So -5 times -3 is 15, and 15 plus 4 is 19. So that's just an example where you have more than one variable. All right, so number 18, again, we have more than one variable, so we're going to plug in 1 for 5, or excuse me, 1 for x, and then -6 for y. 5 times 1 is 5, and 2 times -6 is -12, and I'm using the condensed notation here. Again, if you want to do the non-condensed notation, then it would be plus -12, which is much easier to understand, but the problem is mathematicians just don't typically use that because it requires more work to write it. So 5 minus 12 is -7. All right. So now it's time for you to try one of those problems with more than one letter, more than one variable. And we're starting off with a pretty challenging one here, so do the best you can, and if you make a mistake, that's okay because we're going to do it together. So attempt this problem, And when you come back, we'll see how it works. All right, we're back. So 2 squared times -1. I did not have to put the 2 in parentheses because the coefficient here was +1. But I did have to put the -1 in parentheses because you're multiplying the x squared times y. Whenever you have letters next to each other, it's multiplication. But you have to square this first, then multiply by y. Plug in the 2 to the other x, and the y, the -1, to the y. And just double check that, make sure everything's correct. Everything looks correct. All right, so we've got to do the parentheses first. So everything in here first. I mean in here. So 2 to the second power is 4. And -4 times 2 is -8. And we can go ahead and multiply. -5 times 2 is -10. And again, it doesn't matter what happens over here. Subtracting 10 is going to be you're going to get the same answer. So that's why I'm violating the order of operations and I'm going to go ahead and do this part at the same time to save room. So continue to simplify the parentheses. So 4 times -1 is -4, and -8 times -1 is +8. And -4 plus 8 is 4. And 4 to the second power is 16. And 16 minus 10 is 6. So if you got 6, good job. But that was a hard one. So if you didn't get 6, just go back and figure out what you did wrong. I'm not going to give you that's probably the most difficult problem that we're going to do today. And I'm not going to give you one of those for homework. So that one was just a little bit, a little much for our level here in pre-algebra. But that was good practice, though, nonetheless. So why don't you try number 20, and when you come back, we'll do it together. All right, we're back. We do not need parentheses because this is the rare case where you have a coefficient of 1 and you're plugging in positive numbers. So 2 to the second power and 4 to the second power. So we do the powers first. And we get 4 plus 16 is 20. So if you got 20, good job. So powers first, then you add. That's what PEMDAS tells us to do. So now we're going to use our knowledge that we learned in terms of how to evaluate expressions. But we're going to use our ability to evaluate, and we're going to apply that to real-world formulas. These are formulas that you would actually see if you were an engineer or a scientist. But the difference is, in the previous problems, the expression was just written by itself. But in these problems, the expression is given a name. So, for example, on this first one, this is the expression, but the expression is named E. And by the way, we're not going to write any units in these problems just to make things simpler. So don't worry about your units. Technically, this would be, I believe it's meters per second. That's the speed of light, and this is kilograms, I believe. But we don't have to worry about that because that's going to get kind of confusing. So, like I said, the expression is given a name. The name is E. So these are going to be just a tiny bit different. All right, so it says find E below. So we're trying to find E. And the way we're going to find E is by plugging in the numbers here, and that's going to give us E. And they tell us that M is equal to 10 and C is equal to 4. In the last class, we would write this formula as m times c to the second power. We would use a cross for multiplication. But in this course and every other course after this course, you're not going to use crosses. We just put the letters right next to each other, and that shows that you're multiplying. So let's demonstrate how to do this. We're going to plug in 10 for m, because they give us it's 10 for m and 4 for c. They plug in 4 for c, and we need the parentheses. Notice we need those parentheses, because if you don't write the parentheses, then it looks like 104 to the second power if you move that over slightly. So we don't want that. We don't want 104 to the second power. So you're going to move it over, write your parentheses. All right, so PEMDAS tells us to do the exponents first. So 4 to the second power is 16, and 10 times 16 is 160. And again, we don't need our units, because we're just not going to worry about units today. This is not a science class, it's a math class. All right, number 22, find v below if I equals 2.1 and r equals 0.8. So I is equal to I times r. Now again, in the previous course, and in my arithmetic course, you would have written this as I times r with a cross. But when you get to into upper math, this course and other courses, you don't use a cross. You just get rid of that cross and you write IR. You just write those letters right next to each other. Now again, you're probably thinking, why do we do that? Why do we just write letters right next to each other? Well, it makes it easier for mathematicians to write the expression. Over time, mathematicians have slowly started to condense the notation to make it easier for them. So let's plug in I. I is 2.1, and we show multiplication with parentheses. Now, we could have put both of these in parentheses, or we could have put the 2.1 in parentheses and not the 0.8. Either way, it's you get the same thing. But just be careful. If you had one of them were a negative number, then things might change. If you wrote a negative here, then that would look like subtraction, so you have to be careful about that. So now I'm going to get out my calculator, because we have decimals. This is not an arithmetic course. This is an algebra course, so I'm not going to require you to do the sophisticated algorithm for multiplying decimals. You just break out your calculator, and we got 1.68. All right, number 23. If in the previous course, in my arithmetic course, you would write this again with crosses, 2 times L plus 2 times W. But we don't do that in algebra. We get rid of the crosses and we just write the 2's next to the letters, and that means multiplication. So we show multiplication with parentheses. L is equal to 8, they tell us. And W is equal to 6. So now, order of operations tells us to multiply first. So we get 16 and 12. And 16 plus 12 is 28. This formula may look somewhat familiar. That's how to find the area of a triangle. In the previous course, it would have been written as B cross H divided by 2. But again, we get rid of the crosses. We just write the letters next to each other. And instead of a division sign, we write the fraction sign. This is just the way that we do it in upper mathematics. So we're going to plug in 10 for B and 20 for H. And we need parentheses to show multiplication. 2 letters next to each other is multiplication, so we need those parentheses. And you can put the parentheses around both of these or just one of them. It doesn't really matter, especially because there's no negative number. So 10 and 20, and we're going to go ahead and multiply first. It doesn't, you have to simplify the numerator. We talked about that earlier, or actually in the last class, I believe. You have to simplify the numerator before you divide by the denominator. So 10 times 20 is 200. And then remember, the fraction sign means division, so 200 divided by 2 is 100. so 25 is pretty easy. Why don't you try 25, and when you come back, we'll do it together. Now, you're going to have to use your calculator, though. So plug in those numbers, evaluate R, which is D over T, and when you come back, we'll do it together. All right, we're back. So for D, we're going to write 36.45, and for T, we're going to write 8.1. And I'm going to get out my calculator here. 36.45 divided by 8.1 equals 4.5. So if you got 4.5, good job. Now you may have seen pi before. We haven't learned pi yet, and I'm not going to teach you pi until my geometry course, because I don't really want to teach it until you learn your geometry course, and you're going to learn geometry pretty quick here, so it's not going to be very long. But pi is a very important number, but we're just going to consider that to be 3.14. So, and when the number and symbols are next to each other, that means multiplication. So attempt 26, and when you come back, we'll do it together. All right, we're back. So we show multiplication with parentheses, and you're going to need two sets of parentheses because we have three numbers here. And again, you can put the 2 in parentheses. You don't need, well, actually, you probably do need that. Yeah, you can put parentheses. You can put parentheses on the 2 and the 9, and keep parentheses off the 3.14. There's a lot of different ways to do it. But remember, the purpose is, or the point is just to get rid of ambiguity. All right, so 2 times 3.14. That would be, actually, I'm going to do 2 times 9 first. That's legal. So 2 times 9 is 18. And then 18 times 3.14. I'm going to get out my calculator for that. And I get 56.52. So if you got 56.52, good job. All right, let's do number 27 together. Now, this is your first experience with something that's called a subscript. This really confuses students. Understand that this whole expression here in blue is one symbol. So the x is not multiplied into the v. It's just called a subscript. See how it's a very small x? So that's just one symbol there. So don't get confused by that. All right, so we have b is 6, and we have 2a, so we have to multiply in the bottom. And in the bottom, 2 times -2 is -4. But now you can see that we have a double negative. So these two become a positive, and you have 6 over 4. And use the fundamental principle of fractions to reduce that. You get 3/2. All right, so number 28, we have quite a few operations here, but see if you can do number 28. And remember, the key is you got to use parentheses when you need them. If you don't, it's going to get confusing. So try 28. When you come back, we'll do it together. All right, we're back. So if you wrote -3 squared without parentheses, that's incorrect. That's going to give you the wrong answer. That's going to give you -9. We want to put -3 in parentheses because it's negative. -4 times a times c. So -3 to the second power is 9. And -4 times 2 is -8. And -8 times -4 is +32. Whoops. And 9 plus 32 is 41. So if you got 41, good job. If you didn't get 41, that's okay. Just figure out what you did wrong. All right, so now it's time for you to jump in full scale here. Find f below if m equals 8 and a equals -6. So attempt that problem, and when you come back, we'll do it together. All right, we're back. So m is equal to 8 and a is equal to -6. This is a pretty easy problem. You should have -48. Again, letters next to each other means multiplication, and we show multiplication with parentheses. All right, number 30, find k below if m equals 6 and v equals 1. So attempt this problem, and when you come back, we'll do it together. Remember, you have to do the operations in the numerator first. All right, we're back. And 1 squared is equal to 1. 1 to the second power is equal to 1. 6 times 1 is 6. And now we have a fraction sign, which means division, so 6 divided by 2 is 3. So if you got 3, good job. All right, do number 31, and when you come back, we'll do it together. All right, we're back. So letters next to each other means multiplication. So I'm just plugging in numbers there. And we get 3 times 2 is 6. And 6 times 3 is 18. So if you got 18, good job. All right. Now here's another example where you have a subscript. This is called V0. The 0 here goes with the V. It's not multiplied. It goes with it. So you see V0 equals -3. So don't be confused by that. Try number 32, and when you come back, we'll do it together. All right, we're back. So V0 is equal to -3. That's all of this is V0. And a is 4.5. And we have 2 letters next to each other, which means multiplication, so we have to put parentheses. T is 18. So now we can get the calculator. 4.5 times 18. 4.5 times 18 is equal to 81. And -3 plus 81 is 78. So if you got 78, good job. All right, number 33. Go ahead and try number 33, and when you come back, we'll do it together. All right, we're back. P is equal to 812. And R is equal to 0.09, and T is 4. Now you may recognize this formula from my previous course. That's the interest formula, the simple interest formula. So I'm going to do all of this multiplication at once because we don't really have a lot of room here. And you can use your calculator on that. 812 times 0.09 equals, and then multiply that by 4, and you get 292.32. So we just rewrite the 812 and plus 292.32. So now we add that to 812. 292.32 plus 812 is, I got 1,104.32. So I'm going to shrink this stuff a little bit. So that was my answer. So if you got that answer, good job. All right, so now we have even more subscripts. This is one symbol. This is another symbol. In fact, let me color these so there's no confusion. So the T's are in red and the A is in yellow. So each one of these colors is a totally different variable. But the important thing to understand is those zeros on the X and the V, they go with the X and the V. They're not multiplied into it. It's just sometimes when you have a variable, you have multiple letters on the variable, for example, or you might have a number on the variable. So sometimes variables work that way. It's confusing, I know, but that's just the way it is. So try number 34. When you come back, we'll do it together. All right, we're back. X naught is 8. V naught is -2. T is 5. A is -3. And T again is 5. So a lot of operations going on here. So we're going to simplify this. Actually, we can do multiple things. So -2 times 5 is -10. And we want to simplify the numerator first. So order of operations tells us to do exponents first. So 5 to the second power is 25. And 25 times -3 is -75. I'm going to have to shrink this. First of all, we can do the 8 minus 10. Even though that violates order of operations, it's not going to change our final answer because this doesn't affect whether or not we get a -2 there. And I'm just going to take this negative and put it down in front with the condensed notation. So again, -3 times 25 is -75. And we're almost done here, so if we get a common denominator, multiply both sides of this fraction by 2, we get -4 over 2 minus 75 over 2, which is -79 over 2. Whoops. And there you go. So if you got -79 over 2 or something close, something in a different form, you can verify it as the same form by using a calculator. Divide 79 by 2. Good job. All right, on to number 35. Go ahead and attempt number 35. Again, we have subscripts here. Don't be confused by the subscripts. That's not m times 1 or m times 2. That's one symbol. There are two symbols that go together to make one symbol. That's m1. That's mass 1, and M2 is mass 2. That's what those letters stand for, masses. So try number 35, and when you come back, we'll do it together. All right, we're back. So plug in 2 for G, and 2 for M1, and 3 for M2, and then D is 5. So all we did was just plugged in those numbers. And we're just evaluating the expression. So we have to simplify the numerator and the denominator. So 2 times 2 is 4, times 3 is 12, and then 5 to the second power is 25. So there's not really much we can do with that. So I don't really need such a big fraction line. We can just leave it as 12 over 25. So if you got 12 over 25, good job. All right, so try number 26. Actually, we should do number 26 together because that's going to be a fraction problem. And we just plug in 20 for F. PEMDAS tells us to do parentheses first. So 20 minus 32 is negative 12. And now we're multiplying a fraction by a whole number. So we haven't done that much in this class that I remember. So remember how to do this. You just change the whole number to over 1. And then now we're multiplying two fractions. So when you multiply two fractions, you just multiply the numerator straight across and the denominator straight across. We learned that in the previous course. Negative 12 times 5 is negative 60, and 9 times 1 is 9. But the bad news is that we can still reduce that. We can leave it as an improper fraction because we don't care about improper fractions in algebra, but we do need to reduce it. All right, so we can divide both those numbers by 3. Negative 60 divided by 3 is negative 20. And 9 divided by 3 is 3, so we get negative 20 over 3. So if you got, well, we didn't try that, we did. All right, number 37. I think you can do number 37. That should look familiar. That's the area of a trapezoid. We did that in my last course, arithmetic. So that would be written as h times... Actually, I think I wrote it a slightly different way. I don't remember exactly how I wrote it, but b1 plus b2 in parentheses times h and then divided by 2. That's how we wrote it in the previous course. But in algebra, you see that the notation is quite different, but it's the same operations, just a different way to notate them. So h, well, go ahead and try this problem, and when you come back, we'll do it together. All right, we're back. H is equal to 1. B1 is equal to 3. B2 is equal to 5. So all we have to do is just simplify that expression. So PEMDAS tells us to do the parentheses first. 3 plus 5 is 8. And then 1 times 8 is 8. And then 8 divided by 2 is 4. So if you got 4, good job. All right, on to 38. 38, let's do that together. This is the compound interest formula. We learned simple interest, but we didn't learn compound interest. So this problem, you're going to need your calculator for this problem, definitely. This is kind of an advanced formula. So let's just go ahead and plug everything in here. Principal is 722, that's P. R is 0.05, N is 2, and then N is 2 again, and then T is 2, so we have to use parentheses because we have two letters next to each other. That's multiplication here. All right, so we're going to do parentheses first, PEMDAS tells us. So we have to divide these numbers first, and you can use your calculator for that. So 0.05 divided by 2 is equal to 0.025. And we can go ahead and multiply these together. 2 times 2 is 4. And we're going to continue with the parentheses. 1 plus 0.025 is 1.025. And again, you can do all this in your calculator if you need to. I mean, not all at once, but you have to do it step by step. And now, this is the part that is kind of sophisticated. 1.025 to the 4th power. That you're definitely going to need the calculator for. So if you have a smartphone, you need to put it in landscape mode. What you're going to do is you're going to plug in 1.025 on your calculator, and then you're going to push the button that looks like this, x to the y power. At least that's how my button looks on my iPhone. It may be slightly different on your phone, but it should be x to the y power. You're going to push that button. So you've already plugged in, you've already pushed 1.025. I'm going to move this over. So you pressed 1.025, then you push this button here, the y to the x to the y power, and then you press 4 because that's the power, and then you push equal, the equal sign. So that's going to give you a huge number, which is why this is considered to be a pretty advanced concept here. 1.03. And we're not going to be able to write all those numbers, but you can just write that many numbers. And so keep that number in your calculator. And so that number should be in your calculator. If you already erase it, it's 1.025, and then push the x to the y button. And then press 4, and then push equals. And then you should have that big number in there, and then push times 722. And we get, and we're going to have to write an approximately equal sign because the number goes on forever and ever. So let's round off to the nearest thousandth. So we get 0.953 if we round off to the nearest thousandth. All right, so that was kind of a challenging problem there. I'm not going to give you one of those for your homework, so don't worry about it. All right. I'm going to put that in a square because that means you're plugging that into your, that's a calculator button. So now we're going to do one more thing. We're going to learn how to check solutions. This is another application. So these formulas were all applications of evaluating algebraic expressions, which is what we're learning in part 2 today of evaluating algebraic expressions. But we're going to do one more application, which is learning how to check your solutions. We've done a lot of complicated math equations in this course so far. For example, we learned how to solve equations where you have variables on both sides. But what I have not taught you yet is how to check your answer. There's a way to check to see if your answer is correct. And that's going to use the lesson that we learned today, which is how to evaluate algebraic expressions. So this person that solved this problem, he or she thinks that x is equal to 5. So what we're going to do is we're going to plug in 5 for x here, and we're going to find this value on the left side of the equal sign. Then we're going to plug in 5 to the x here and evaluate the expression on the right side of the equal sign. And if our answer for the left side is equal to our answer for the right side, then that means 5 is a solution. So if that sounded kind of complicated, don't worry, you're going to get the hang of it. It's pretty easy. So we're going to plug in 5 wherever we see an x. So I plugged in 5, and then if we simplify, if we evaluate this and evaluate this, and they both equal each other, then 5 is a solution. But if they don't equal each other, 5 is not a solution. So 5 times 3 is 15, and negative 4 times 5 is negative 20. 15 minus 1 is 14, and negative 20 plus 34 is 14. They both equal each other. Therefore, we're going to write yes. That means that x is a solution. Or excuse me, 5 is a solution. So if you solve this equation, you should get 5. If you don't get 5, that means you did it incorrectly. All right, so let's try number 40. So y, they're saying y is equal to negative 2. So we're going to check that. So we're going to plug in negative 2 wherever we see a y. Whoops, I need a negative 2 there. So we're going to have a double negative on that one. And we need parentheses because we have negatives next to each other. So on this side, we don't really have much to do because there's only a 7. So all we really have to do on this problem is just evaluate this side. So this is a double negative. It becomes, well, first of all, we can go ahead and divide. So negative 2 divided by 2 is negative 1. And then 4 times negative 2 is negative 8. Then we have a double negative here. So that would become positive 1. And 1 minus 8 is negative 7. And negative 7 minus 1 is negative 8. So we end up with negative 8 is equal to 7. Is that correct? No, it's not. So we write a slash right there. And we say no, because y equals negative 2 is not a solution to that equation, because negative 8 does not equal positive 7. So again, you evaluate the left side of the equation, you evaluate the right side of the equation, and if the sides equal each other, then the solution solution is correct. But just be aware, we're not going to be adding or subtracting and putting stuff on different sides of the equations. We're not going to be doing that. That's if you want to actually solve the problem. We're not solving the problem. Okay, all we're doing is we're checking the answer, plugging it back in, and verifying that the answer is correct or incorrect. So let's put rectangles around our answers there. And I want you to put a rectangle around your final result also, because I want you to actually show your work. If you don't show that final result, that means you didn't actually do it. I'm well aware of the fact that there's a 50% chance that you can get the answer correct. So don't play games. Just do the work. All right, so number 41. Well, why don't you go ahead and try number 41, and when you come back, we'll do it together. All right, we're back. So we plugged in 4 for every z value. And we're just going to simplify, so we get 6 over 3 minus 1 equals 12 minus 11. So again, you have to do the numerator part first. 6 divided by 3 is 2. So then we have 2 minus 1 is equal to 1. And 12 minus 11 is equal to 1. So 1 is equal to 1, so we can say yes, z equals 4 is a solution. So if you got that right, good job. On to number 42. Go ahead and attempt number 42, and when you come back, we'll do it together. All right, we're back. That's that rare case where you don't need parentheses on that first term there. And 2 to the second power is 4. I'm just going to do this step by step. And negative 2 times 2 is negative 4. Negative 4 minus 4 is 0, and we end up with 1 is equal to 2. And that is not correct. So the answer is no. X equals 2 is not a solution. So if you got 1 is not equal to 2, and your answer was no, good job. But again, you have to do both. You have to find these numbers, and you have to say no, or else you didn't actually do the problem. All right, try number 43. When you come back, we'll do it together. All right, we're back. And there you go. Negative 14 is equal to negative 14. And the answer is yes. Y equals -5 is a solution. So if you said yes and -14 equals -14, good job. All right, try number 44. When you come back, we'll do it together. All right, we're back. I'm going to put that in condensed notation. Then we have a double negative, which becomes positive. And again, I'm using condensed notation for all of these. It's very confusing to use condensed notation. There's nothing we can do to fix that problem. You just have to learn the language. There's no way around it. All right, 6 minus 2 is 4. 4 minus 3 is 1. 1 minus 5 is -4. -4 minus 10 is -14. So obviously you can see this doesn't work. So it is not a solution. So we say no. All right, we just have 6 more problems and then we're going to be done with this class. Whoops. Try number 45, and when you come back, we'll do it together. All right, we're back. We can get a common denominator here. So 4 minus 21 is -17. And you can see that's not even close. So the answer is no. It is not a solution. Try 46, and when you come back, we'll do it together. All right, we're back. So 0 equals 0, which means that it is a solution, so we write yes. And again, I want you to rectangle both of these. All right, 4 more problems. Try 47, and when you come back, we'll do it together. All right, we're back. So 2 times 0 is 0, and -5 times 0 is 0. You can put a plus or minus sign, it doesn't really matter. 7 times 0 is 0. So 0 minus 0 is just 0. Those go away, and then you're left with 0 plus 4. And 0 plus 2 is 2. And 0 plus 4 is 4. And 4 does not equal 2. So no. Y equals 0 is not a solution. All right, try number 48. When you come back, we'll do it together. All right, we're back. -2 times -3 is 6. -8 times -3 is 24. -4 times -3 is 12. 6 plus 30 is 36. 24 plus 12 is 36. So you can see that that is a solution. So yes. So you can use this to go back and figure out if your solutions are correct. Of course, with my homework, you don't need to do that because you can just look at the answer. But this is going to come in handy when you don't have the answer available. For example, when you take my tests, you're not going to have the answer available, obviously, so you need to check your answer to make sure that you score well on the test. You need to demonstrate that you can do that on your own without seeing the answer. All right, so try 49, and when you come back, we'll do it together. All right, we're back. So again, PEMDAS tells us to do the multiplication first, but you should be getting to the point where you can kind of skip you can cheat a little bit. You get negative 39 if you combine these numbers. Minus 9. 3 times negative 3 is negative 9. Negative 3 times negative 3 is positive 9. And then negative 2 times negative 3 is positive 6. So again, we're using all kinds of condensed notation, and we're doing PEMDAS out of order just because we can in some cases. So this is all stuff that you need to be slowly starting to understand as you get more and more experience. Now, if you're not doing the homework, you won't understand anything. That's for sure. So negative 39 minus 9 is negative 48, and 9 plus 6 is 15. So that obviously does not work. We rectangle that, and we say no. So we have one last problem. And by the way, if you got 49 correct, good job. So attempt number 50, and when you come back, we'll do it together. All right, we're back. So you definitely need parentheses in this problem. Parentheses here because you're plugging in a negative. Now, if you weren't plugging in a negative, that you could just write it as negative 3 squared without parentheses. That would be fine. But because you have a negative 3, you have to put parentheses. It's not splitting hairs, it's correct notation that's going to cause you to get the correct answer. So I'm just double checking that. Looks good. Negative 3 to the second power is 9. 7 times negative 3 is negative 21. And negative 9 plus 1 is negative 8. And negative 21 plus 2 is negative 19. So you can see that that doesn't work. So it is not a solution. No. All right, so that is the class today. This is all the work that we did today. If you want to take screenshots to help you with your homework or tests, go ahead and do that now. So let's go ahead and look at the homework. So that's your homework, so get a screenshot of that. Notice you have all the solutions as usual, and don't forget this this last page here. Get a screenshot of that, and get that homework done completely and correctly. And remember, if you don't do the homework, you will learn nothing in this class. I guarantee it. So I'll look forward to seeing you in the next class.